Hey, I wanted to talk about reviewing AI-generated code. Nowadays, it's pretty common for most of us to work with coding agents, and usually when you give a coding agent a task, depending on the complexity of the task and the complexity of the code base, the agent is going to make a few changes, and sometimes it ends up making changes with that spans across a lot of different files. And once the AI agent is done, you're typically left with a list of files that you're supposed to review before you commit to your code base. And you end up doing this several times over a day. And sometimes it gets frustrating and you just commit whatever the AI agent gives you. So it's a very human problem. It's oftentimes I'm also clueless about where to start reviewing the code or what to look for. And this is one of the reasons I ended up building something that helps me get a good idea about how to review and what to look for during reviews. And as I go through these reviews every day, I also end up building a good understanding of the system that I am working on. So this is the diagram. So this is very similar in the sense it has the same information that you saw in the previous list of files that were changed. You typically have the name of the file, and underneath each file, you also have what was changed, like typically the number of additions, deletions, etc. And these little potted plants, they say that these are new files, right? So you still see there were 10 files changed, same as the one that you saw in the previous list of files. And when you have a diagram like this is basically a dependency graph, a simplified dependency graph. And when you have something like this, the first thing that you notice is there is some directionality of how these things are connected with one another, right? And you will also notice some of these are of different colors. So the colors are based on the file extension. So all the Go files are marked as white, but all the test files in Go are marked in green. And you also have a README file, and the README file is basically having a different color. So that helps you direct your focus on which files to review in what order. The second thing is when you start to review a change set, you always start from the right side of the screen. The reason being, if you look at how the diagram is laid out, especially in a diagram like this, you'll see the low-level components are on the right side of the screen, and then the high-level components are on the left side of the screen, which means as you move from right to left, the number of dependencies start growing. And conceptually, when you're working on the smaller component first, you get a good sense of the mental model that you have. And then you gradually are building the mental model as you move towards the left, which makes it easier for you to reason about the solution that the AI has generated for you, right? So in this case, I'll just go through like on the kind of things that I would look for. For example, I look at parser Rust. So I know this is a Rust parser. And I also see there is an associated test. And now I would take a quick glance at the number of lines that were changed, and both of these are new files. If you see, this one has 120 lines of code and this one has 42 lines of code. So typically I would expect tests to have a lot more lines because it's very hard to capture behavior or the specification in fewer lines. Sometimes it's possible if you're using something like property testing or snapshot testing, but oftentimes it's not. So at this point, I know I have a parser in Rust, but it's also not very well tested. So that's one area that I would like focus on, probably not in the same flow, but in the next task. Then I also see there is a dependency resolver. So it uses a Rust parser to parse the document, and then probably it's indexing all the symbols and trying to figure out or constructing a graph that it will later use to resolve dependencies and then draw a graph. I also see there's a module for Rust, and this one deals with Rust language. There's so many other languages that the tool support, so I know that that's there. And then I also know that there's one more thing that is related to detecting test files in a given programming language. So this one looks pretty neat, right? So, and on the leftmost, you have the language registry. So the language registry accesses the Rust module, and then everything else is just like the internal part of the Rust module, right? So this is where I'm sort of like happy with where this is. This may not do exactly what I want to do. I may have to add more tests, test it somewhere else to see if the parser or the Rust language support works in multiple cases, but this is fine, right? The next thing that I would see is I have 3 files that were changed, and this one is a pretty small change, and then there are like also a couple of changes here. The first thing that I would be concerned about is why are they not dependent on any other tests here, right? Or production code. So that would be concerning to me. So I would want to understand why did these files change and why are they not connected to one another, right? So that would be my angle when it comes to reviewing these files. So I'll probably go to the test file test again here, and where is it? Test file test. And here it looks like it's a pretty simple change. So this file is just specifying a couple of paths and then checking if the Rust module detects it as a test file. So it's a pretty simple test. It's not directly connected, but I believe it could be working with it's hooking into the system somehow, but I'm okay with this. Then I would go look at supported language test. Supported language test, where is it? And here, if you look at it, again, it's very similar. It just checks for Rust support from this function. So this function, which means the implementation happens with the registry. So that's why no changes in production code happen, but you can still make sure that the test is capturing that behavior. So I'm also okay with this. And it is decoupled because it's supposed to be decoupled. What do you call this? You call this open for extension, closed for modification. So I'm sorry, I didn't get that right. I have to think about it. And then the last one is language command test, and this one has one line change, but this is not associated with any other file. So I'd go take a look at it. Language command test. So this one just prints out the Rust extension. So we have a command that prints out a list of supported languages, and the new behavior just captures this. So what I would say is the language registry is doing its job, because everything else, like detecting Rust files, test files, and also detecting supporting languages, all of those are working as long as I keep adding things to the language registry. So there is no coupling between these, which is what I want. That's a quick overview of how I go about reviewing files. I do this every time my agent generates a bunch of code, makes life a lot more easier. There are like a bunch of patterns that keep coming up over and over again, but I would talk about those in the future. But this is the workflow. So usually what happens is the agent finishes making its changes. Then I run the sanity tool to generate this graph. Then I review the graph from the left to the right. Sorry, from the right to the left. I also look for test files. I look for coupling. I also look for the number of files that were changed. And I also try to build a mental model of how my system looks like. And if I find any discrepancies, or if I find something interesting, then I go and look at the actual code, right? And I do have enough number of tests, and the compiler guarantees me some sort of safety. So there are moments where I know that I probably have to just look at the diagram and keep moving. So I will drop a link to the tool in the description. Go check it out. And if you have any questions, just reach out to me.